All right, so good afternoon, everyone. So our next topic will be about standard library functions. So what are standard library functions? So these functions are already inbuilt functions in C programming. So the definitions of these functions are written in their respective header file. So for example, you have already encountered using printf and scanf in your programs, right? So if you want to use your printf or your scanf for your standard input and output na tasks, you just have to include the stdio.h na header file. So this standard na library functions, you just use these functions because these functions are already provided by your C na program. Okay, so you don't have to redefine what a printf or a scanf it. You don't know how it works, but you can just reuse it in your programs. So yeah, so there is at least one function in any C in a program, which is the main. So this is where the program is called when it begins. Okay, so let's have an example. One function, one predefined function in C that you can use is a square root function. So it is defined under the header file called math.h. So if you want to use the square root function, you just have to include this math.h na header, like how you include the stdio.h na header file for your input and output na tasks. Okay, so here's an example. So here you include the stdio.h and then the math.h na program in order for you to use standard built-in functions in C, like the printf, the scanf, or the square root. Okay, so again, this printf and scanf are functions that may be used when you include this header file stdio. And then the square root can be used if you use the math at each program. So here's a program where you simply have to you simply declare two variables num and root, and then you ask the user to enter a number which saves it into the scanf na program. Now, this concept actually is what we call as abstraction. Okay, so wherein you use a certain function without knowing how it works. Okay, so you use scanf, but in your compiler there is another set of codes that define that scanf na function. Okay, so also, same is true for your square root. For your square root na function, so you just reuse this square root function that is defined in your math.h. So here are other standard library functions in C, and you can do research on your own. So you have the C type.h and the math.h and then the stdio.h. You have already have been introduced with this one, the std live, string.h, time.h, etc. Okay, so we also have the user-defined functions. So the user-defined functions are functions that you, as the programmer, define. So according to what you need. So okay, so before we go over the formal rules for defining a function, let's look at three simple programs first that define a function. So first, I have a question. Why do you have to define your own functions? Because in C, um, not all functions that you need are provided. So that's why you have to write it in your own. Okay, so let's say we have this program which computes averages. So suppose we often need to compute the average of two, let's say two double na values. So in C, C doesn't have an average na function. So what we can do is define our own. So this is an example of the average na function. So you have a compute average na function with a return type as well as the parameter. So this earlier, what you have specified is we need two double na values. So we have the variables A and B, which refers to the double values that we need to take the average for. So, and then inside the compute the average na function, we define what that function will do. Okay, so here, let's observe first this first line. It is divided into three parts. So this part is the return type. So the return type is any valid C na data type. So it's the type of data that the function returns every time it is called. So in here, we have specified that it is double. So why is it double? Because you wanted to compute for the average of a two na double values. Of course, the average will also be you also have the name of the function, the compute average, and followed by the a parenthesis that encloses the parameters. Okay, so in here, the parameters are A and B. So the A and B refers to the number that will be supplied when the compute average is called. So what we have to remember is that each parameter must have a data type. So in this case, the A and B are double. And of course, inside your function, you have your function body, or which refers to the executable na part of the function. So we have the compute average, and now we will define what it will do. So how can you compute the average? So you simply take the sum and divide it by 2. And then also we have the return statement, which causes the compute average na function to return to the place which it was called. Okay, so earlier we have defined our compute average na function. Now, if we want to use this compute na average function, we have to call it. Okay, so to call a function, we write the function name, which is the compute average, this compute na average, followed by a list of arguments. So the arguments are what are the information that we supply to a function. So in this case, your compute average needs to know which two numbers to average. So we have defined here that our compute average accepts or two double na values. Okay, so when we call our function, we pass here the value of the value of the two numbers that we want to take the average for. So so for example, we have the 3.3 and the 5.4. So this 3.3 and 5.4 will be mapped to the to these parameters that we have set. So we copy the values of 3 by 3 and 5.4 into the parameters A and B. So now your A will be 3.3 and your B will now be 5.4. So here's the whole na code. So what we are doing here is computing the pairwise na averages of three na numbers. And here is the function that we have defined to compute for the average of the two na numbers. So, and then in this part, in your main program, so, okay, so notice that we now have two functions. We have the main and then as well as the compute na average. So firstly, we declare three variables, X, Y, and Z, and just prompting the user to enter three numbers. And now, in these three lines of codes, we are computing for the average of X and Y, Y and Z, and X and Z. So notice that you are simply reusing the compute average na function without necessarily redoing or rewriting this these two lines of these lines of codes for each of the values that we want to compute for. So we simply reuse the compute average na function. So, and the only difference is that the values that we pass. So for this first line, we are calling the compute average na function with your x and y na values. And then for the second line naman, we compute for the average of y and z. And then for the last na line, we compute for the average of x and z. Okay? So, right. So what we are doing is to the these arguments that we supply, let's say the x and y, those are copied into A and B. Okay. So now your A will now be x and your y will now be your B will now be equal to the value of y, and the function then computes for the average of A and B. And later, once you are done with computing the average of A and B uh, and uh, and saving or storing it into your variable average, this average may now be returned to the main. Okay, so it returns the computed average of A and B to the main function. So now the value of this compute average function will be the value that was returned by this function. Okay. So note that the return value of compute average isn't saved anywhere. So the program then prints it and then just later discards it because it returns a value but you don't save it anywhere. So you just print it out and then later mawawala na yung value niya. Okay, so what we can do to store the value, store the return value in a variable is to revise our code. We add additional line wherein we set or we store the return value of compute average to this AVG variable. Okay, so here's the example na output. So let's say you have entered 3, 4, and 5. You have where 3 is your x, 4 is y, and then 5 will be stored to z. So, and then you calculate for the average of 3 and 4, 4 and 5, and 3 and 5. So, remember that the function can often be called as often as we need. So, as a recap, in the previous example, we have computed the pairwise average of the numbers. And we wrote a compute average function that accepts two numbers with a type double. So, and once it computes the average, it returns to this computed value to the caller. So in this case, that you call the function average, compute average in the main, so it also returns to the main function. Okay, so but however, not every function returns a value, which we will discuss in the next video.